All right, happy weekend, everybody. Whether it be Friday, Saturday, Sunday, or Monday that you're watching this, let's do this. This one's a little bit longer, so I do want to give you the full weekend to get it done, okay? Lesson 533, we're going to do the whole class as a class, or the whole lesson as a class, so please stick with me here. And you will need your review preview, pen, paper, and a calculator, red pen. Okay, the first thing we're going to do, please be aware of the homework. It's 117 to 122. 117 to 122. Okay, so please make sure you, I'm sorry, 117 to 119 and then 122. 117 to 119 and then 122. All right, let's get going here. Okay, so we do have a warm-up. I'm sorry, I forgot to mention that. We do have a warm-up just because I do think this is a skill that we need to practice. It's something that has caused some issues or that might be challenging, and so I want to make sure that we get it covered. So if you could please pause the video and go ahead and do this, and when you're done, unpause it, and we'll talk about it. All right, so here we go. You should have done it. I wanted explicit and recursive for both of these. So right here, you might notice, right here, we are doing what? We are subtracting 5 each time. So let's go with my, explicit first. So T of n equals negative 5n plus, I do need term 0. So if I worked backwards, I would get 9. So negative 5n plus 9. Okay, now let's do the recursive sequence. So T of n plus 1 equals T of n minus 5. And then I just need the first term or term 0. So T of 1 is 4. And just because you don't have to do this, but I'm just going to share it, just in case you did the other one, T of 0 equals 9. Now let's go to the next one here. Now you look at the next one here and you might be like, okay, 2 to 7 and then 7 to 24 and a half. Well, I'm not adding the same thing, so I probably am multiplying. So it's probably a geometric sequence. So 2 times what gives me 7. Now, hopefully you know that, but if not, you can always divide the second number by the first number, and you should see that you're multiplying by 3.5. Now, if you do that again, you should get 24.5, okay? So let's go ahead and this time let's focus on a recursive sequence first. So T of n plus 1 equals T of n, what? Times 3.5, okay? Times 3.5, where T of 1 would be 2. Now, if you wanted to, again, you don't have to, you could do T of 0 instead. And you're like, whoa, wait, how do I do that? What is 2 divided by 3.5? Because we have to go the other way around, right? 2 divided by 3.5. Now you could say a bunch of different ways. You could put it several different ways, but the answer would be 4/7, okay? 4/7. Or 57, it's an irrational number. So you're like, how am I supposed to do that? Well, you could do 2 divided by 3.5. You could also say it's 2 divided by 3.5, which of course I don't want a decimal there on the denominator. So if I multiplied everything by 2, I'd get 4/7 and get an equivalent equation, which is how I got that, okay? You didn't have to do term 0, that's okay, I just wanted to point it out. Now, what about the explicit equation? I'm not telling. Listen, the explicit equation we haven't officially learned, and I know some of you are like so mad at me right now because you're like, you know how long I worked trying to figure out the explicit equation for that second one? I know. That is what we're going to cover some of tomorrow. Okay, so we're going to do some of that tomorrow, and hopefully that'll make a lot more sense. If you want to try it, that'd be awesome. I would love for you to try this. Go for it. Try to find the recursive equation, but I'm not going to throw a lot at you. We've got plenty to do. So I'm just going to pause right there. Remind me, and we'll go over this tomorrow. Okay? All right, review preview. Please pause the video and check your answers to the review preview. If you do have questions about anything here, please make sure that you contact me or email me or ask me on Tuesday, and I'll be glad to answer. Or you can also, again, email me on Monday, and I should be in school and can help you out with that. Let's begin. Today, 533, is it a function? Comparing sequences to functions. Now, we've talked somewhat about this, so I do think this lesson should go fairly smoothly because it's something we've already kind of addressed. Throughout this chapter, you've been learning about sequences. In chapter 1, you started to learn about functions. But what is the difference? In this lesson, you will compare and contrast sequences with functions. By the end of the lesson, you will be able to answer these questions. Is a sequence different from a function? And what is the difference between a sequence, t of n, and a function, f of x, with the same equation? All right, so here it is. 511, please write down this sequence right here. Write down the sequence. 5, negative 1, 3, 7. And now here's what we're going to do. We're going to modify this a little bit for the sake of time. It says create multiple representations, basically a table, a graph, and an equation, both recursive or explicit for the sequence t of n. The table, let's do the table here together. So the table, this is n and this is t of n. Okay, and I've got 1, 2, 3, 4. Doesn't really tell you how far to go. Let's go to 5. Okay, and then I started plugging my values: negative 5, negative 1, 3, 7, and hopefully by now you see the pattern. What's the pattern? You're adding 4 every time. So the last number here would be 11. If you want one more, 6, it would be 15. Now, for again the sake of time, what I want you to do is I want you to make a sketch of the graph. It's not going to be on graph paper, even though technically it should. It's going to be a sketch. So please pause the video, take about 2 minutes maybe max, and graph this data. Cool? All right, the sketch. When you do your sketch, first of all, what do I need? I got negative and positive. But all my values my t of n values are positive, so I just need quadrants 1, which is this 1, and 4. So I just need quadrants 1 and 4. We don't need anything else. And this is y and our x and y. Okay, so 1 is negative 5, which would be somewhere around here. 2 is negative 1, which would be somewhere around here. 3 is 3, 4 is 7, 5 is 15, and I don't remember 6. But get the point right there. Should it be discrete or continuous? Well, if you remember what we said in class, this should be a discrete graph because, again, we can't plug anything in between. If you plug a value in between those two sequences, it becomes a new term 2 and messes everything up. So it should be discrete. Cool. And now, recursive or explicit. You should be good with this. So please write me the recursive or explicit equation for this. Actually, it wouldn't be a bad idea if you did both. So pause the video and do one or both, whatever. And I'm going to do both here in just a second. Okay, so I'm going to start with the explicit. So t of n equals, and if you notice here, my slope or my growth is always 4. So 4n plus term 0, which I don't have, but if I went back to term 0, it would be negative 9. So 4n plus negative 9 is my explicit equation. My recursive equation, t of n plus 1, would be t of n, and then plus 4. With t of, don't forget it, t of 1 being negative 5, or t of 0 being negative 9. There it is. Cool? Hopefully that went pretty well. All right, now what I want you to do is we're going to compare. Letter B, is it possible for the equation representing t of n to equal 4? Let's do that. Is it possible for the equation representing t of n to equal 400? Now, on the quiz, this kicks some of your butts. We are saying, does t of n, does the output, can it equal 400? Justify your answer. So we're replacing the t of n with 400. So do that, please. Okay, so my equation was t of n equals 4n plus negative 9. So if I replace 400 with that, I get 400 equals 4n plus negative 9. I add 9n plus 9, and I get 409 equals 4n. Now, honestly, at this point, I could stop because you know what I noticed? This is an odd number. And if I'm going to divide by 4, well, am I going to get my answer? Well, am I going to get a whole number if it's an odd number? No, I'm not. It would be 102 and 2500ths, or in a fourth. So, is it possible for this to represent a t of n to represent 400? No, it is not possible because the terms must be whole numbers, which is what a lot of you shared with me, which is pretty cool. All right, what we're going to do now is we are going to create the same multiple representations that you did in part A for the function f of x equals 4x plus 9. Okay, so I want a table, a graph, a sketch of a graph, and then, well, I kind of already have the equation, don't I? So I guess I don't have to do anything, just a table and a graph. So please just do the table first, and then we'll go into the graph. Again, do the table. When you're done, unpause this video, and we'll see if you got it right. Okay, so here is the big catch, and this is why I stopped you first. If I've got x and f of x, at this point, if I don't give you values, you know what I want? These are the values I want. Same that we did with x and y. If it was x and y, I want you to go from -3 to +3, -3 to +3. Now, I know my y-intercept is -9. I know my slope is 4, so -5, -1, 3. But then working backwards, -13, -17, and -21. So that is what I would want to see as a table for this situation here. The graph, it would need all 4 quadrants this time, okay? And again, since this is a sketch, we're going very quickly. 3 would be -21, which would be like way down there. 2 would be -17, which would be maybe here. 1 would be -13, which maybe would be here. 13, or that's not very good. Okay, 9 maybe being here, then 5, then 1, then 3. So my graph would look something like that, except I'm not done. Should this be continuous or discrete? In this case, it should be continuous. Well, that 3 point was not very good there. This one, it should be continuous because I can find all the value or the values in between. So how are they different? Well, write some ways. Please list at least 2 ways that they're different. So one of the big things that they're different or one of the big things is it is a continuous graph, meaning we could find the decimal. So I could find value 1.5 for x and get a number here for y. I could do that, which would be -3, right? I could figure that out right there. So it should be continuous versus discrete. The other big thing, though, is that for f of x, x can be negative, whereas on T of n, we cannot have negative values. We just can't have negative terms, okay? So those are the 2 biggest differences that I need you to keep in mind. For the function f of x, is it possible for f of x to equal 400? Explain why or why not. We don't have to redo the work, do we? Okay, so please go ahead and answer that question. Could it be or not, and why? Or why not? Well, if you remember, we solved it prior, and what do we get? X equals 102 and 2500ths. So could it be? Yes, we could find that value. It is possible for f of x to equal 400 because x could be a whole number or a decimal that is perfectly within the rights. Okay. Next problem, 5112. Let us consider the differences between T of n equals 2 times 3 to the power of n, and f of x equals 2 times 3 to the power of x. And you're like, what on earth is this? Well, yeah, it's a hint. If we did arithmetic sequences before, this is probably geometric, right? This is a geometric situation. Now, is f of x equals 2 times 3 to the power of x a function? Why or why not? Is T of n equals 3 times 3 and a function? Now, please remember what the rules are for a function. Can you tell me? The rules for a function are that every input must have one and only one output. So if I replace anything here for x, like 1 or 5 or 10, do I get only one answer or do I get multiple answers? Well, try it out. If x is 1, would I get multiple answers or would I just get one answer? How about over here on T of n equals 2 times 3n plus 1? If I type in anything for 1, do I get one answer or do I get multiple answers? Okay, Both of these are functions because they have a single output for each input. Write that down. Both of these should be functions because they both have just one output for every possible input. Now, this next part, something new, so please focus. Is it possible for t of n to equal 1,400? If so, find the value of n that makes t of n equal 1,400. If not, justify why not. Now it's t of n, all right? So t of n, write this down, equals 2 times 3 to the power of n. This 1,400 is equal to t of n, so 1,400 equals 2 times 3 to the power of n. Will you take a second and try to solve that and see if you can figure it out? Okay, if I was going to solve this, the first thing I'd have to do is actually think of order operations. If I gave you a value here for n like to the 5th power, what's the first thing I would do? I'd do the exponent, and then I'd multiply by 2. So remember, when I'm undoing things or solving, I work backwards, doing the opposite. So the first thing I want to do is it's multiplying by 2. I want to cancel that out by dividing both sides by 2. Then I get 700 equals 3 to the power of n. Now, how would I do that? Well, 3 to some power gives me 700. How could I do that? Well, at this point, what I want you to do is just start on your calculator and start with 3 to the 2nd power. Now, some of you, you got the x squared, right? 3 squared, 9, okay? And you're like, okay, I can do that. What about 3 to the 3rd power? Well, in your head, you can kind of do that, right? So in your head, you should be able to do 3 to the 3rd power is 27, and then it gets bigger and bigger and bigger. So you could just do 3 times 3 times 3 times 3, and 3 times 3 times 3 times 3, and keep going like that. You can also do the Cherokee, so 3 to the 3rd power, okay? But I want you to find it, okay? 3 to the 2nd power, 3 to the 1st is 3, 3 to the 2nd is 9, 3 to the 3rd is 27. What about the rest of the terms, okay? So please take a minute and go ahead and find that right now and get that information and see what you got, okay? See if you can find it, see if it works. All right, if you did it, 3 to the 4th power is 81. 3 to the 5th power, ooh, and it's amazing how quickly it goes up, doesn't it? Is 243. 3 to the 6th power, 3 to the 6th power is 729. Oh, wait a minute, right there. Notice an issue here? Look at this. 3 to the 5th power would have given me, so if n was 5, I would have gotten 243, which is way too low. But if n was 6, it would be 729, which is too high. So it must be somewhere between 5 and 6, isn't it? So if n has to be between 5 and 6, can this work? No, because once again, all the terms must be whole numbers, and this is not a positive whole number. So therefore, t of n cannot equal 1,400 in a sequence. Hopefully that makes sense. How about this? Is it possible for f of x equal 1,400? If so, find the value of x that makes f of x equal 1,400. Be prepared to show how you found that. Now look, at this point, kind of the same idea that we just did before. Am I asking for the exact answer? Some of you might be able to actually find it, but probably not. It is not the easiest math, and it is not a math we're going to kind of learn really at all this year. That's not the focus of this year. But I do know from the work I just did over here, this right here, 3 to the 5th is 243, 3 to the 6th is 729. So it's not a whole number. So can f of x equal 1,400? Yes. Even though we don't know the exact value, the value of x has to be, I could say, okay, 5 is less than or equal to x, which is less than or equal to 6, right? X has to be greater than 5. Oh, it's not equal to. X has to be greater than 5, but less than 6. But I don't know exactly what it is. However, it can work. We can find the value of x, or we could have a value of x that is not a whole number, and it would work for f of x, okay? So are the two functions similar? How are they different? The functions are the same equation, but t of n is discrete and f of x is continuous. Okay? So f of x is discrete, f of x is continuous, t of n has to be discrete. That's the biggest difference. All right, that is it. So what you're gonna do is, you can pause the video and read the comic if you want to. Otherwise, you're gonna start with the homework. The homework, I gotta go back just so you can see it again. So if you wanted to read it, you can pause it and come back to it, or come back to it later. But the homework is problem 117 through 119 and then 122, okay? 17, 18, 19, 22. Got it? All right, I hope you have a wonderful weekend and I will see you on Tuesday.